Good evening, everyone. Thanks for being brave and survive till end of the conference day and coming from this very last talk of today. My name is Vojtěch Juránek. I work as a developer at Red Hat, and in this short talk, I like to tell you something about how to feed the machine learning models with the data from the database. For questions, if there are any, please use Slido, as you probably know. Before we get started, let's take the look on this big picture. If you have ever run machine learning model in production, you probably know that it's not about writing the model and training it. It covers many other operations which are usually called MLOps, and ingesting data into the model is only one of many of them. So we will concentrate only on this small part. But definitely this is a very crucial task, because even the best model without any data is basically useless. So basically the problem I'd like to discuss today is following. Imagine you have a running business, all your applications are running, you are storing the data in one or several databases, and then you hear about this machine learning stuff, that it's cool and can help you a lot. So take a look and find out that it actually can help you, and you can get more from your data. And now you need to solve questions how to pass the data from your databases into the machine learning model. Of course, your favorite machine learning model probably can support some loading of the data from the databases, possibly using some SQL queries, or you may come up with your custom service, which again probably will query the database, or possibly will do the dual writes, one to the database and second one to your machine learning model. And there are possibly other approaches how to do that. But when you start to have more requirements for your data, like that you want to have consistent state of your data, you really never want to miss any data which is stored in your database, or basically some technical requirements like that you don't want to overload your database with SQL queries. This can become quite a hard problem. And when you add a requirement that you want to process your data in your model in real time, and you should do so because the life is real time and so should be your data, then the problem is even harder. So basically, what to put instead of this question mark? And my answer to this is to change data capture and DBZoom project. Quick disclosure here, I'm a DBZoom developer, so I'm a little bit opinionated here, but I truly believe that this is a good approach how to do that. So for the agenda, in the first part, I will quickly tell you what the DBZoom is and how it works. And in the second part, I will quickly describe my experience, how it can work with popular data processing and machine learning frameworks like Apache Flink and TensorFlow. So first, what is the change data capture? It's basically a process which, as the name suggests, monitors the database, captures any changes which are happening to the database and convert it into stream of events. The DBZoom is an open source project which is leader in this area and implement the change data capture, and it does it in a way that it monitors transaction log of the database, which is the source of truth for most of the databases. So basically, if you are interested in, for example, in changes in tables outbox, which is in pink on this picture, then DBZoom connects to the database, monitors transaction log, and if there is any change related to outbox table, being it insert, update, delete, or even schema change, it will create a record about the change and push it somewhere into the event stream. This somewhere can be some messaging system. DBZoom was originally developed as a source connector for Kafka Connect, and most of our users still, I guess, use it with Kafka. So basically, you deploy DBZoom as a Kafka source connector in a Kafka cluster. It connects to your databases, captures the changes from there, make a stream of data from it, and push it. Kafka will push it on the other side to sync connectors, which can do whatever you like with the data. For example, you can mirror the data in some data pool, invalidate the cache, update the search index, or possibly push it into your machine learning model. If you don't like Kafka, and would you like to do something else, you can do it as well, because we provide DBZoom also as a standalone server, which basically does the same, but instead of pushing the events into the Kafka, it will push them into other popular messaging system like Pulsar, Google PubSub, or into data memory in data grids like, for example, Redis or Infinispan. We cover most of the popular databases like Postgres, MySQL, Oracle, or Mongo. We have some connectors which are in incubating stage, like, for example, connector for Google Spanner. And there are still some connectors which are being developed, and actually not all the connectors are maintained under DBZoom umbrella, as some database vendors selected DBZoom to implement their change data capture process, but they develop it themselves and also maintain it themselves. This is, for example, if I remember correctly, ScyllaDB and Gigabyte, for example. And there's more. DBZoom is not only about change data capture. It can also, for example, allow you to take a snapshot of your database state. So basically, capture the current state of your data, and typically it's done in a way that before you start streaming, you take a snapshot of your database, and then you start streaming change to this data. And there are a lot of other nice features, like, for example, UI for easy configuration, or a Kubernetes operator for easy deployment in a Kubernetes cluster. We provide embedded engine, which allows you to embed DBZoom directly into your application, but a lot of more. This is a brief list, and I will even go through this list because I have lack of the time, but the main message from this slide is that DBZoom is not about only change data capture through the main task, but it's pretty feature-rich platform. So back to our original topic. As I said, DBZoom is in many cases used with Kafka because Kafka is extremely popular messaging system. And this is also the reason why popular machine learning platforms or data processing platforms also support Kafka. So probably the easiest way how you can deliver the data from your database to your machine model is to use DBZoom to connect to your database, push it to Kafka, and try to read this or let your model fetch the data from the Kafka. Here is depicted for Apache Flink, and it works really nicely because Flink works really nicely with Kafka. But actually, in case of the Flink, you can do even better. You can completely skip the Kafka because Flink has built-in support for DBZoom, and actually you can just take Flink and run DBZoom directly from Flink. As this is pretty short talk, I don't have time for demos, but if you are interested in demo, you can check our GitHub repository with examples. There is machine learning folder, and you can find all the examples here. And we have also a blog post on our DBZoom webpage. So if you are interested in details, please check here. But I can't resist just briefly show you the code. You don't need to read it. This is for the harder part, the upper picture when you read the data from Kafka. And even this, let's say, harder part, is that easy that it fits into one slide. On the left is dbZoom configuration in Kafka, and on the right is a short Flink program, which at the top creates a Kafka stream. Then it deserializes the records. Then I defined a model there. It's k-means clustering, which is an online learning algorithm, which is later on fitted or from the stream of the Kafka events defined above, and on the top button, this model makes a classification of incoming data from another Kafka stream. So basically, it fits into one slide. That easy it is and works really nicely. And I have to say that, of course, I didn't write the model myself. It wouldn't be that short. I'm using built-in a Flink machine learning library for that. So Flink works nicely. What about TensorFlow? It's probably the most popular library for building more sophisticated models and deep learning models. So fortunately, also TensorFlow supports loading events from Kafka. So everything, again, looks nicely until you run it, because you will probably find out that for some reason, TensorFlow interprets all Kafka values as strings. So basically, if you have tables with some numbers, let's say, dbZoom grab it, serialize it, push it into Kafka, and TensorFlow will deserialize it, these events, as strings, which are basically pointer representation of these arrays. So it's then completely useless. So is everything in vain? Fortunately not, because one of the nice features of dbZoom is single message transform. It's a Kafka Connect concept which dbZoom adapted as well, and it allows you to modify every outgoing message. So it can be used for whatever modification of message you want, but also for other really useful things, like, for example, filtering messages. So as dbZoom would be at the very beginning of your machine learning pipeline, it would be very useful to do the filtering here, because you can save a lot of bandwidth through the whole your pipeline. But for our problem, and there are a lot of prepared SMTs, and to write your own custom SMT is really simple. And for our problem, we can use it because as TensorFlow interprets the Kafka values as string, we just basically, what the simplest way how we can fix it is that we take, for example, our array and converted it into a CSV line, which we push to Kafka, and then TensorFlow will deserialize it, and on the top, we just need to add this small function which will parse the CSV line and cast it back to the numbers. And then, as you can see, again, reading from Kafka and then pushing it into the TensorFlow model is really straightforward and easy. Again, we have another example and blog post for TensorFlow. You can check it again or on our web page. And that's basically it. So my key takeaways from this talk is that change data capture is a really powerful concept because it allows you to convert the data from your database into real-time stream. So basically you can run your machine model in real time, and you can also leverage some powerful machine learning algorithms like online machine learning, where you can train your model online and at the same time make online predictions from data you are getting. And dbZoom is popular change data capture framework, which allows you to do that, and it's very easy to use it with at least these frameworks. And we try, for example, also with Spark, and again, works really nicely. And one more thing is to remember SMTs, because single message transform are a really useful tool which can help you to fix a lot of issues, for example, the integration issues, as you can see. So that's it. Thanks a lot for your attention. If you find DBZoom interesting, try it. And DBZoom has a very big and vibrant community. So if you have any issues or ideas how to improve it, don't hesitate to join us on Zulip chat or via Google Groups and let us know. You will be really welcome there. So that's all. And if there are any questions, let's check Slido. No questions? Okay. So thanks a lot for attending the last talk and enjoy the rest of the evening.